We live in a universe with massive amounts of structured and unstructured data. Let's take an energy company that is trying to create a safe environment for its employees as an example. Jack is a safety analyst who analyzes potential safety issues, near miss accidents, and accident reports. He is tasked with devising new safety procedures, milestones, and compliance procedures. His challenge? Dealing with memos, procedures, investigations, and reports that come from various elements of the organization, each having their own nuanced observations and inferences of what constitutes risk and safety. So, how can AppOrchid help? First, Jack needs to train the system with vocabularies, institutional terminologies, and safety procedures. He accomplishes this by loading glossary terms, organizational content, and rules. Based on prior training, the system classifies the information and organizes it within its graph database. Notice how the machine learning classifiers have separated out entities under buckets such as safety, working conditions, hazard conditions, OSHA issues, etc. Such a graph that captures business entities, their relationships, and interface rules is called an ontology. Notice how each graph element is rich in metadata content, along with the interface aspect like best output formats and analytical displays. Here, an item called Employee Safety has a time dimension and a safety dimension, indicating a spatial-temporal association to the organization. Notice how each visual component, called a microapp, has its own nuanced visual curation technique optimized for maximum information delivery. The system processes the training content and, based on responses to interactive queries, will provide the most optimal organization of content to maximize comprehension and information throughput. Jack starts his investigation by training the AI system to understand safety guidelines and operating guides. Notice how there are three types of content: a structured dataset, soft datasets like OSHA regulations, and fluid data like investigation notes. First, the AI system performs an unsupervised learning procedure to detect the strongest and weakest links. Notice, in this example, the system has detected unsafe condition data as the most frequently occurring accident condition. The vocabulary is wired in to understand unsafe and condition as different attributes that qualifies the health of a work environment. Notice how the system, automatically based in the comprehension of its vocabulary, has tagged unsafe condition with the hazard object. Next, the system performs a series of supervised learning techniques to understand features and contents of the file that might be indicative of a safety situation. Notice how a hazard detection bot has extracted all sections within the document that have a danger sign associated with it. Next, the system curates the knowledge and presents the outcomes through a visually rich interface for the user to annotate and perform reinforced learning. Tribal knowledge and workforce intuition can be organically captured and parameterized. The system dynamically configures a neural network with the appropriate weights and biases derived from interactive user queries, leading to a deeply intelligent system capable of continuous learning and self-adaptation. Through iterative training and knowledge amplification, the system can learn significantly over time and adapt to changing conditions and results. Finally, the machine learning functions, the natural language interface, and the visual cues need to be packaged, curated, and presented to the end user for optimum experience. By blending different microapps, new apps can be cross-pollinated. Notice how our new safety app is built dynamically by combining spatial temporal features and accentuation features. The natural language-rich ontology allows search results to be queried with a Google-like search interface. To support a truly IoT ecosystem, the app interface should support smart devices as well. By combining a micro-app for detecting accelerometer reads, it is possible to identify hazard conditions like slippages and falls and trigger safety actions automatically. AppWorket's AI-based platform combines the Internet of Things, processes, and people's tribal knowledge to unlock enterprise-wide wisdom creation and curation through apps that have diverse applications in the field of energy, life sciences, and risk management.